are going to continue our investigation of systems of inequalities. So once again, we're going to be looking for the area where two different inequalities intersect. So we're finding the numbers in the coordinate pairs, the ordered pairs, where it makes both of the inequalities true. And we're going to be doing this graphically. So let's go ahead and take a look at a similar problem like we did last class. So this was the one that's a little bit more difficult. So we're going to be working on the one where one is a parabola and the other one is a inequality of a line. So let's go ahead and jump on in. So today we're focusing on another example. And so it is more systems of inequalities. And we're going to be looking at two inequalities. Our first inequality is going to be y is less than or equal to x squared plus 2x minus 3. And our second inequality is going to be y is less than or equal to negative 2/3 x plus 2. So taking a look at these two inequalities, once again, a part of our goal of algebra is for you to take a look at each equation and have a little bit of information about what they might look like before we actually solve them. So for our top one, as you can see, it's an x squared, so you should be thinking that this is a parabola. It has a positive coefficient. It is a positive 1. So we know that our parabola is going to be an upwards parabola. If it was a negative x squared, it would be a downstairs, kind of like an umbrella parabola. We also know that at one point the parabola is going to cross the y-axis at negative 3. We know it's a fairly just moderate parabola. If it was steeper or skinnier, we'd be looking at a different coefficient. Now, taking a look at our second one, we can tell that that's a line. We have a line and it's going to cross the y-axis at 2, and it's going to be a negative slope. So it's going to be going downhill as we read it from right to left. To go from one point to the next, we're going to drop down 2 and go 3 to the right. So let's go ahead and jump on in for our very first one, which is going to be that parabola. So we're going to take a look, and we are going to actually use both techniques that we have in order to do this. We're going to use the quadratic formula, and then we're going to do it using a generic rectangle diamond problem. Now, we haven't yet been tested on the quadratic formula, and there will be a problem on the Chapter 9 test where you will be required to use the quadratic formula, which is why we're going to practice it one more time today. So here is the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now remember, when we have two letters next to each other, it means to multiply. And as we're going to be replacing these with our numbers, we want to make sure that we are putting parentheses around for when we use those in our calculator. So now we're going to go ahead, and for both techniques, we take out our a, our b, and our c. So when we take our a, that is always the coefficient of our x squared, and it's our invisible 1 right now because there's 1x squared there. Our b is our coefficient of our x, so that is a 2. And our c is our constant, which in this case is negative 3. So we're going to go ahead and replace every place we see a b with 2, every place we see an a with 1, every place we see a c with negative 3, once again putting parentheses around as we solve. So x is equal to negative 2 plus or minus the square root, and we're putting parentheses around our b in this case, 2 squared minus 4 times a, we're going to put a 1 in parentheses, c, put our -3 in parentheses, extend out that square root, all divided by 2 times 1. Okay? Now that we've replaced all of our letters for numbers, it's time to go ahead and focus on solving the problem underneath the square root. So we have our 2 squared, and our second problem is simply going to be multiplying these three numbers together. Make sure you're including the negative because that's going to be a -4. So our next line is going to be x equals -2 plus or minus the square root. 2 squared is 2 times 2, which is 4. Remember that first number will always be positive. -4 times 1 is -4. And -4 times -3 is positive 12. All divided by 2 times 1, which is 2. We're continuing to simplify underneath the square root till we get a single digit underneath there. And we have x is equal to -2 plus or minus the square root. 4 plus 12 is 16, all divided by 2. Now, 16 is a perfect square because we know that 4 times 4 is 16. But if it wasn't a perfect square, we would pause here for our exact answer. Because it's a perfect square, then our final answer is also going to be exact. So once again, we're going to grab our calculator. If you're not sure what that square root of 16 is, we're going to put that in our calculator. Remember, you're going to press the second button, and then you're going to press the x squared because underneath that x squared is the square root. And we're going to put in 16. So the square root of 16 is 4. So this is where we're going to split it into our two roots. We're going to follow our two paths, -2 plus the square root of 16 divided by 2, and -2 minus the square root of 16 divided by 2. So -2 plus 4 divided by 2 is our first x, and our second x is -2 minus 4 divided by 2. -2 plus 4 is 2. 2 divided by 2 is 1, so that is our first root. -2 minus 4 is -6, and -6 divided by 2 is -3. So these are our first, our roots, our first points from our parabola. We have one at -3 and our second at +1. Okay? So this technique is using the quadratic formula in order to find your roots. Now we're going to go ahead and find the roots our second way, which is using a generic rectangle diamond problem. So if I jump on in here, for my diamond problem, I use those same A, B, and C's. A times C is -3. I put that in the top of my diamond problem. And my B goes on the bottom, B bottom, B bottom, B bottom. There is only one way to multiply to get a -3, and that's 1 times 3. And one of those needs to be a negative, and I know that 3 minus 1 is going to give me that +2. So now I'm going to transfer my problem into my generic rectangle. My x squared goes in the bottom left, my -3 goes in the upper right, and I've split my 2x into a -x and a 3x. After I've set up the generic rectangle, I'm ready to factor and find the outsides. The only way to get an x squared is x times x. X times 3 gives me 3x. And to turn an x into a -x, that's going to be times -1. We're now going to write it in product form. X plus 3 times x minus 1. After it's in product form, I'm going to use the zero product property in order to go ahead and solve for my roots. So I'm going to set each of these equal to 0. And then I'm going to go ahead and solve for each of those x's. So we have our first root at -3. And our second root here, by adding 1 to both sides, is going to be at +1. So once again, this is two different techniques to find the roots of our parabola. Our quadratic formula will always work, whether your answer is a decimal or not. Sometimes we do get into the situation where we have a diamond problem where we can't find two numbers that multiply to be the top and then go to the bottom. And then we would be forced to go over and use that quadratic formula. So we're halfway there. We have our roots. Now we need to go ahead and find the vertex. Now there's three different ways as well that you can find the vertex. Now, if it's a really nice one like it is here, we can simply find the middle of our roots because we know that parabolas are symmetrical. They're equal on both sides. So if I move together, I can see that my vertex is going to have an x-intercept of -1 because that's right in between my two roots. That's 1. However, sometimes my roots are actually going to be fractions or decimals. So I have to do that algebraically. There's two ways to do it algebraically. The first is I'm going to add my roots together and divide by 2. So -3 plus 1 is -2, and -2 divided by 2 is -1. And once again, that's the x value of my vertex. My other technique is simply using, once again, my A, B, and C. So my vertex, my x value, is always going to be -b divided by 2 times A. So you can use that to find your vertex as well. So in this case, my -b would be -2 divided by 2 times 1. And that's how we would get that -1 for your vertex. So that's halfway. We need a y value now for our vertex. Once again, we have two techniques in order to do this. And generally, it doesn't matter which one you use. You want to use which one works best for you. The first technique is to plug those numbers into product form. So that number is our x. So that would be -1 plus 3 is 2 times -1 minus 1 is -2. 2 times -2 is -4. So that would give me my y value of my vertex. The other technique is to plug that -1 into my original equation. Now notice when we use the quadratic formula, we do not have a product form. So if we use the quadratic formula and need to find the vertex, we need to use our original equation. So when we do that, we're going to plug in -1 squared plus 2 times -1 minus 3. -1 squared is +1. 2 times -1 is -2, and -2 minus 3. 1 minus 2 is -1, and -1 minus 3 is -4. So once again, as long as you're doing your calculations correctly, it doesn't matter whether you plug it into the original equation or into your product form because there are two ways to write the same item. So now we're going to go ahead and plot that vertex, -1, -4, onto our form. We also have a bonus point, and our bonus point is our y-intercept. So we're going to mark a -3 on our y-intercept, and we're going to go ahead and do 1 to the left of that as well because it is symmetrical. Now it's time to focus on my inequality sign. It's less than equal to. So I know it's going to be a solid line. So we're going to go ahead and make that a solid line and draw our parabola. Now we need to decide, are we going to graph inside or outside? Now the less than is kind of less than the point on the vertex. So less than means that I'm going to shade outside of my parabola. However, we want to verify. And the way that we verify is we pick that point. I pick 0, 0, and see if it's true. So is 0 less than or equal to? 0 squared is 0, plus 0 minus 3 is -3. Is 0 less than -3? My answer, of course, is no. 0 is greater than -3. So that means that this point made a false statement, so it should not be shaded. So we're going to go ahead and we are going to shade outside our parabola. And once again, we want to shade in a manner that is nice and neat and something that you're proud of, because we're going to be doing a double shading. So we need to make sure that we are shading to the point where it's very obvious of where we are shading, and we're shading carefully. Now remember, everything that's on the line of that parabola is also going to make that statement true. When I say make that statement true, what that means is I can pick any ordered pair anywhere on my shaded portion of my graph here, and it's going to make my red equation true. Anything that is not shaded on the inside of this parabola, for example, the point -1, 2, if I plug in a -1 for x and a 2 for y, that's going to make a false statement. So everything that is shaded, continuing forever in all directions there, is going to make it true, and anything that is not shaded is going to make that inequality false. Okay, so we're halfway through. Now we're going to go ahead and graph our second inequality here. This one is a line because it has a plane x. So first we go ahead and plot our y-intercept, which is +2. So we're going to put a dot on the y-axis at 2. And then we're going to go ahead and move our slope. Once again, our notes on the 14th and 15th of April go in detail of how to graph and how to move your slope and what your inequality means for a line. So that -2 means I'm going to go down 2. That +3 means I'm going to go 3 to the right from this portion. So I'm going to go down 2 and 3 to the right. That's my next point. I'm going to continue this down 2 and 3 to the right. Down 2 and 3 to the right. I'm going to switch both directions of my arrows to go the other direction and continue my line up. That means I'm going to go up 2 and 3 to the left. Up 2, 3 to the left. Up 2, 3 to the left. Up 2, 3 to the left. Okay, now I'm going to go ahead and take a look at my inequality. This one is also a solid line. Remember, if it was just a less than, it would be a dashed line. So make sure you are paying attention to whether you are drawing solid lines or dashed lines. Okay, make sure you go all the way through, arrows on both ends. Now, looking at that, it's a less than. We know in lines, less than is below. So we're going to go ahead and shade below that line. Once again, doing a nice job with your shading. Now, once again, we want to verify. If I look at the point 0, 0 here, you can tell that it's shaded by my blue. So when I plug in the point 0, 0, it should make that inequality of my line true. And so 0 is less than or equal to 0 plus 2. 0 is less than or equal to 2. It's true, 0 is less than. So that means I should be shading this side. Now it's time to go ahead and finish and analyze what the graph actually means. So everything that's in this white area up here is going to make both equations, any ordered pair for x and y, is going to make both of these false. Anything that is just in the red-orange area is going to make the orange equation true only, and it's going to make the blue false. Anything in this kind of little part of the parabola here that is just blue is going to make the blue equation true when I plug in the ordered pair for x and y, and it's going to make the red false. However, anything that is my double combined area, for example, the point -6, 1, when I plug in a -6 for x and a -1 for y, it's going to make both of those true. Anything that is on a solid line is going to make that true, and we're going to go ahead and outline a little bit stronger. Anything that would be on a dashed line would make it false. So I'm just going to kind of outline here. Now remember, these do continue forever and ever going out. And this, ladies and gentlemen, is the visual graphical solution of the inequalities y is less than or equal to x squared plus 2x minus 3, and y is less than or equal to -2x plus 2.